Hello everyone, this is going to be just a really quick tutorial which came out of today's class where somebody was asking how to model a pavilion like this. It's the ICD Research Pavilion, I think it's from Stuttgart, and how would you go about doing this? And I think for something that, if you wanted to keep something smooth like these curves are, one of the best programs to use is Rhino in this case. So we'll use this combination of Rhino and Grasshopper. And looking at it from a lot of different point of views, the first thing I'll observe is that this thing is more or less a half sphere which has been chopped here and here. So we'll try to approximate the surface on which this is on. So I'll start with a sphere just at the very center, and it really does help us to actually be at the center point. Maybe if we have grid snap on, yeah, there we go there. And let's, okay, that looks like 15. We'll try to work as much as we can to scale. So that's saying that it's say 2.5 meters roughly in diameter. We can always scale it afterwards. So we'll take this. Let's create a sphere. I'll turn on shading. And okay, so the first thing was we'll split it just with a line. Chop it there, and again, this doesn't have to be a straight line. We could also make those other cuts with the curve. So I'll chop it there and there, and I'll just go split, and the object to split is this, and we'll use the cutting objects of that just to remove this part here. And we'll try splitting it with this and this. We should be able to delete that and that. We'll get rid of these things. So there we have the surface of our design. Now I'll start up Grasshopper because to me this is a very algorithmic type of project. And the first thing we should notice about this design is that all the curves that are on it pass through the surface. So to me, one of the easiest ways to do it is to intersect the plane at which this thing lies with the surface, and to define a plane being like a 2D infinite, like an infinite space in 2D. Think of something like a piece of paper but stretched out forever. The minimum amount of data you need to define that is 3 points, or 1 point and 2 vectors. So I think the mechanism we can have is we'll use this as one of the anchor points. We'll use this for the second anchor point, and we'll do a third that goes down the middle. And just to help us out, maybe we'll rotate this so that the middle of this line goes through the center, because that way we could actually go. I think there's some built-in planes. Like if we look at the YZ plane, be very tiny. Actually, that looks like it's running that way. So what we might want is the, let's say, the ZX plane or XZ plane. So delete that. And this looks like it's running. Okay, that's running the right way. So if we take this and we put our surface just into a little container, where our surface is right here. Select this surface as that. We can now hide this so that everything else becomes more visible. And you'll find there's under intersect, I think the one I was looking at was B rep pen plane. being boundary representation. So if we slice this and this, you've got a line going down the middle. So we can think of that as our meridian line, where every point has to pass through that. Alright, so we'll keep that that surface as being the host for all the surfaces. Now what we'll do here is prior to the circle shape, the sphere shape is pretty annoying to deal with. So what we'll do is we'll actually grab some curves off it. This probably isn't the most flexible way of working, but I think it might be the simplest to explain. I'll bring the surface back, and what I'll do is I'll go curve from duplicate edge, and I'll duplicate this edge and this edge. Looks like this thing got sliced unknowingly. Let me just try hiding it for a second, and then these two, I'll try joining them. I would like that to be one curve and that to be one curve. And then what we'll do is we'll put each of those curves, go here, into a container. We'll set this one here, and we'll set this one here. And these curves can be evaluated at a point between 0 and 1. So if we go evaluate curve, for example, here, by default I don't think they'll be parameterized, so if I do this, it'll only move, as you can see, a little bit along the curve, almost something you can't see. But if I right click on this and say reparameterize, that point gets divided between 0 and 1, so you can see how that dot moves across it. And we can do exactly the same with, we'll move all our base geometry here, reparameterize again, and we'll make a copy of this, except all we'll do is we'll swap the curve for this one. And this way we've got one way of moving this slider, and then one of moving this, and we have another curve over here. So again, we'll just delete again. We've got these 3 points, and this one we'll take out of this curve. Did that? Oh, it looks like it's intersecting. I think it's because what we need to do is we'll move this into here, and then reparameterize it. This thing's being somewhat annoying. Where did that point go? It should be... Oh, sorry, I've clicked it in the wrong place. So if this goes here, and this goes inside here, see, we're moving across it, across the surface of that. So we've got basically 3 parameters that we can use to then make a plane, which is just under plane by 3 points that can be A, B, and C. And we've got and it'll be a very tiny, because of the scale we're working at. It'll be hidden somewhere in the corner. But if we take the same idea, and basically we just need this plane intersected with this, you can see this green line here at an angle. If I hide the surface just for a second, and I'll hide our meridian line, which was this one, you can see that we've got preview that. Okay, we've got this curve where we're controlling its movement on this line. It kind of disappears if you go too far there. We can control its position here, which is like the angle, and we can control this one here, which is this line here now. We could go one by one, creating each of these lines, but one of the beauties of Grasshopper is that it works with lists really well. So what we'll do is, let's say we want to do 20 at a time. It could actually be a variable amount, so let's make a slider that's just integers between 1 and let's put the high up as high up as 33. And what I'll do is I'll take this under sets we have sequences where it just repeats data. All it does is it takes this point and repeats that by here twice. Let's move that up to 20. So this is 20 copies of the same thing, and that was for our top this point over here, and I'll do the same here, repeated with this other point, 20 of those. And for our meridian point, rather than repeating it, what we want is we want it to jitter a bit. Like, so we wanted, let's say, we know that this is 0. Actually, let me just quickly check. This is on this curve. This is 0, and this is 1. And we want, say, between a bit of randomness between negative 0.1 of that and positive 0.1. So if we create a set of random numbers, we can actually use this to say how many. The first thing will be our domain. So we'll say this is between, say, negative 0.1 and 0.1. So we'll take this value here, and then we'll just add. We'll add to it just using addition. We'll add this number plus this number here, this random number that comes out, and right now it's set for one number, but we can easily use this to say, okay, create 20 of those. And now we have these 20 points, and so rather than evaluating it just at this one point, we'll evaluate it at these 20 points. So we'll get copies, multiple copies of them. And the way we can spread it out is, that the domain that we have for this is between negative 1 and 0.1. If we create a new domain, let's set the edit this to its minimum value can be negative 1 and its positive 1 will. So with it again, let's say negative 1 and positive. Okay, so here we'll use this to create a new domain. Let's say positive 0.2. We could use this to bring it into this, and we can use that as a way of stretching the movement of it. Remember, we can still control all these other aspects of it. We can say where it begins and where it ends. Maybe it would help if we could see the surface, because otherwise we'll keep making things that cut through it. So we'll preview on. Okay, so and now because it's doing 20 of them, there's no reason why we can't say do more. We'll just keep baking it a few times with that. So if we go bake that there, now rotate, rotate this to here, and then we'll bake that there. Let's try one at the very edge. So let's try one that goes to the edge, but maybe goes to here, and we'll make them much closer to each other. and let's it looks like, okay, because we say it has to go through, like we might have made a bad choice in meridian line over there. Perhaps it would have actually been smarter to have it run this way. So actually let's see what would happen if we swapped that this one here. Let's see if we go, what did we choose? The XY plane. If we went for the YZ one, let's try that. What would happen if that swapped for that? Would we be able to? Okay, we could get much more curves running this way. So let's make it again. We'll just do one more and then let's say go to the other end and the other end there. Okay, there we go. And maybe we'll make this thing spread out more, and then again bake that. Alright, and if we look at all these curves we've made, if we want to give them, like for example thickness, we can just we could use the I mean within Grasshopper you can type make the diameter say 50. Maybe that was too much. Let's try diameter of 10. Yeah, so we've kind of got and you can see these are incredibly smooth curves, and we could have made way more of them, but yeah, hopefully that'll be useful, and it's another reason why I think Grasshopper and Rhino are a good combination.